Hello, my name is Philip Lackescher and welcome to a short summary of my master's thesis with the title A Potentialization Algorithm for Games with Applications to Multi-Agent Reinforcement Learning. Let's start with the motivation. One approach in the domain of multi-agent reinforcement learning is to take existing single-agent methods and deploy multiple learners together. However, a problem that is frequently encountered in this setting is that those algorithms often do not converge or do so very slowly. This can be attributed to the fact that the agents learn independently from each other, but they constitute a part of the environment and thus change the environment for one another when they learn and their policies and thus their behavior evolve. Hereby the fact that the agents usually have different incentives and thus are often rewarded differently for a particular combination of their actions is mathematically modeled in the form of strategic form games. In my work, I first introduced an algorithm that creates for any strategic form game an approximate potential that summarizes the incentive of all players to deviate from one action to another in one numerical value. Thereby I assumed that the agents may learn better when they are guided by this potential than without. In order to test this assumption, I randomly generated instances of 10 times 10 games and 4 times 4 times 4 games and created the approximate potential according to my algorithm and then simulated both instances with the replicator equation, for which the formal connection to reinforcement learning was established in previous work, and the form that I used and is visible here is equivalent to the policy progression of Q-learners with greedy action selection. Both cases, 10 times 10 and 4 times 4 times 4, in the amount of steps in which approximately 90% of the potential-based instances converged, only 10% of the original instances did so. However, thereby the rewards for potential-based instances were on average 90% of the original counterparts. The diagram on the left shows the progression of the maximum policy distance, which can be seen as a measure of convergence until the convergence of the potential-based game instance. On the right side, the average agent rewards are displayed, whereby for both cases it is visible that the progression of the curves for the potential-based instances were smoother than those without. In summary, the agents converged faster when they were guided by this potential and achieved a comparable average reward, so that the potentialization algorithm might constitute a viable approach for some applications in this regard.